In the previous video, I'd mentioned deadlocks and what deadlocks means. So today I figured how why not have a practical example of how you can prevent deadlocks in your code, similarly to how operating systems prevent deadlocks. I'll open up my Visual Studio. So for those who didn't watch the video, deadlock is a situation where you have two or more processes trying to access the same resource. Yeah, opened my Visual Studio. Um, yeah, this is just what is this? Release notes. So some code I had written to teach some people. Okay, we can create a C++ file. We call it deadlock deadlock.cpp. Sorry, deadlock.cpp. We can paste this here. Yeah, paste this here. So we're going to use mutual exclusion primitive. Mutual exclusion primitives are used by in C++. We use them to prevent two or more threads accessing a particular memory location or a variable. Variable is a memory location. So you can imagine if a memory location with values, numbers or text or whatever like value, and then we are having two competing threads trying to access that particular section where the variable is or the memory location. If we don't do it in a manner that is not going to cause the application to crash, the application will crash. So the mutual, they call it mutual exclusion. Yeah, the mutual exclusion primitive assists in that, so that you can build multi-threaded applications that can run without crashing. Yeah, so we're going to use threads. We're going to use threads for this case. A thread is a process is, but you can correct me on the comments. A process is like a program, an instance of a program running, and then a thread. A process can contain many threads. So yeah, so you have a process inside it. You can have so many threads. But you can correct me on the comments. We are here to teach each other. So I'm going to start with the first mutual exclusion variable. I call it A. Then I go to the second one. I call it B. And then we can now define our. I'll use two. Then now we'll just use two threads to run this. Don't worry, you will follow. You will understand what I'm doing towards the end, I'm sure. Don't just embrace the confusion. So here we can say thread one. This is the first thread. So what is thread one doing? Thread one is getting hold of A, locking it, also getting hold of B, trying to lock it. Then after doing what it wants to do with it, with A, it unlocks it. To unlock, yeah, for B, just unlocking it. Then what else can we do here? Yeah, we can try to visualize this, visualize the execution of this program so that you can be able to follow. And I like using what is it called? I like showing using text, like this is where we're at in the code, this is what is happening. I'm tired. There's a word for that, but I don't know, it's slipping me off. So here we can say thread one is locking A. Then we can end line. End line is like a new line. We're trying to have a new line. And say it's locking B. Here we can say it's locking, yeah, it's locking A. Here you can see it's locking B. Unlocking. Yeah, so this is what thread A is doing. I just copy this and you can copy it entirely. What is happening? Copy it entirely. thread 2, thread 2. So now, instead of starting with A, we can start with B, so that each thread starts with the different mutual exclusion thread. So this is thread 2. Once you run this, it will be clear. I'm sure you'll follow. It will be in your janja. Locking and locking. Thread 2 is locking. So in C++, main is where everything runs. Like that's where you run your thing. So here we're going to run those two threads. So to do that, we're going to create an instance of the two threads. We do this by having this being on the parameter. This now. So this is what AI does: code completion. AI is going to replace humans. So now, once we have our threads, then now we can start them. Join. To join. This space, there's nothing here. Yeah, here we can say that program has ended, so that we're able to simulate how the flow is. So I've saved. Let me run. Wow! Don't tell me we have an error. Oh yeah. So as you can see, it's saying thread 2 is locking B, thread 1 is locking A. Then it's ending there. Don't know why it's not even getting to this point. So, oh, this is a deadlock. Why is this a deadlock? As you can see, we have the first thread. The first thread is trying to access, has actually accessed A, then it has locked A. And then it tries to go and access B and lock it. However, as you can see, the second thread accessed B and locked it. It also wants now to access A and lock it, but now A was already accessed by thread 1. I hope you're imagining now what is happening. We can probably try to let's have one thread running and we see what happens. Yeah, you see now thread 2 is locking B, thread 2 is locking A, thread 2 is unlocking B, thread 2 is unlocking A. The program has ended. You can see. So this is among the ways you can make your program, application, app run in a manner that you reduce on the crashes, but also you can say your application is multi-threaded. So the user experience is good. I don't know if you've ever used your laptop and then it tells you there's a process trying to access something else, and then now it's loading, and then now it's for you to decide, should I go on with that process or this? So similarly, you can have that in your program. I'm really sorry, I'm tired, but asanteni sana for enduring this towards the end. I appreciate. If you have any questions, weka hapo kwa comments. I'll try to answer them. Asanteni sana.